Okay, solving rational equations. So here's a rational equation. It's two fractions that are equal to each other, and when that is the case, the cross product should be equal. So 7x is going to equal 15, and then we can divide by 7, and x is going to equal 15/7. Okay, we can use that same strategy on this next problem, even though it's a little bit more complicated. We can the cross products will be equal. So when you do this, be careful. It's 9 times the quantity x plus 1, and it's 3 times the quantity 4x plus 5. So that means we're going to have to distribute on both sides of the equation. So here 9x plus 9 is going to equal 12x plus 15. And I can solve that for x pretty quickly. All right, so let's subtract 9x from both sides. And then add 5. I'm running out of space. Here, I can get that in. Oh, sorry, subtract 5, I mean. And then divide by 3. And then x is going to equal 4/3. Okay, next up, here's some suggestions for solving rational equations. First thing I would do in general, I mean, if you can cross multiply, that's great. On this next example, we're not going to be able to do that because we have more going on than just two fractions that are equal to each other. Okay, so my first advice would be to clear the fractions, and you can achieve that by multiplying the entire equation by the lowest common denominator. It really doesn't have to be the lowest common denominator. It can be any common denominator, but it'll make things easier if it's the lower it is. Okay, and then also you want to watch out for extraneous solutions because those can happen sometimes. So extraneous solutions in rational equations are going to happen. Like say I got 8 for a solution in this next problem. Well, that would be no good because it would make the denominator equal 0. I can't have 0 denominators. But sometimes you might get algebraic solutions. You might get that solution algebraically, but when you plug it into the original equation, it wouldn't actually work. Okay, so the first thing I would do with a problem like this is space it out. So you can see I have this spaced out because I'm going to be multiplying everything by something. So I'm looking at these denominators. 2 of them are x minus 8. That's great. And then one of them's a 2. So I'm thinking, what do x minus 8 and 2 both go into? 2 doesn't go into x minus 8. I can't factor a 2 out of it. So what I'm going to have to use as my lowest common denominator is 2 times the quantity x minus 8, or you could call it 2x minus 16 if you want. But I think it's easier to just leave that denominator factored, okay? So I'm going to multiply the whole equation by 2 times the quantity x minus 8. So this first fraction, when I multiply it by this, I can just put it on top. I'm really just multiplying the numerators because I could put that over 1, right? And then, so if I'm multiplying this fraction by that, it's the same as just multiplying the numerator by that, okay? And I'm going to put that on all 3 pieces, right? All 3 terms are going to get multiplied by 2 times the quantity x minus 8. That's why I spaced this out so that I would have room for everything there, okay? And then I'm going to do some canceling. So the x minus 8's cancel, the 2's cancel here, and the x minus 8's cancel again. And then when we look what's left, there's not going to be any fractions left, right? I canceled all of the denominators. It should always work like that if you multiply the whole equation by a common denominator, okay? So this first term, I'm going to distribute the 2 over here. So all that's left from this first piece, I've got 4x minus 10. Second piece, I'm going to distribute this x over here. I've got x squared minus 8x. And then on the right side, 11 times 2 would be 22. Okay? So now I'll start to clean this up. So only one x squared term. I'll combine 4x and negative 8x. Okay? Now I want to set this equal to 0 so that I can solve it. So I'm going to subtract 22 from both sides. All right. And now I've got something that I can factor. And even if I couldn't factor it, I could still use quadratic formula or complete the square. So let's see. I believe this one is factorable. I'm looking for two numbers that add to -4, multiply to -32. 4 and 8 will work if the 8 is negative. So this factors into x plus 4 and x minus 8. Okay, and I still haven't solved it, but now zero product property, one of these products has to equal 0, so x is going to equal -4, or x is going to equal +8. Okay, but then especially when you get two solutions, really you should always check any solutions that you get. But I want to go back to the original problem. If I plug in a -4, well then I'll have -12. There's nothing wrong with a -12 as a numerator. But if I plug in a +8, that's no good, right? In the original problem, it would give me a 0 denominator. So that means this is my only viable solution. This one is extraneous. Okay? All right, let's try another out on the next page. Similar type of problem. I would again space it out so that I've already done that here. My lowest common denominator, I'm thinking okay, I got x minus 1s, that's great, but then I've got a 6. So what do both 6 and x minus 1 go into? They both go into 6 times x minus 1. Okay, so that's what I'm going to multiply all of my numerators by. Oops, x minus 1. And I forgot the plus sign here, so there it is. Okay. I got some extra parentheses there for some reason. Oh, that's what I forgot there. Okay. And now I can start canceling. Okay, so all I have left from this first piece is 6. Then I got a 6x for that second term. Last term, I'm going to have x squared minus x. Okay, and now I'll clean this up. 6x and -x is 5x. I'll set it equal to 0 by subtracting 6 from both sides. And hopefully we can factor this. If not, again, always quadratic formula or complete the square are options. Okay, looking for numbers that multiply to 6 to -6. So using a 2 and a 3, one of them would have to be negative, and that way I'm not going to be able to make them add up to 5. It feels like I would be able to, but you can't. But I can do this with a +6 and a -1. Okay, and then if x plus 6 equals 0, then x equals -6. And if x minus 1 equals 0, then x equals 1. And I want to take a look at those. So I'm just doing a spot check. I'm just looking for possible 0 denominators. Nothing wrong with the -6, doesn't give me 0 denominators. But this one does, right? This one is extraneous because it would give me a 0 denominator on both those first two fractions. So this one's extraneous. Okay, and that's all I have today. I'll see you next time.